Have you ever wondered how colossal ships manage to traverse the narrow land strip between the Atlantic and Pacific Oceans, known as the Panama Canal? This marvel of engineering is a testament to human ingenuity and perseverance. The Panama Canal, a 50-mile stretch that connects two vast oceans, is strategically located in the narrowest part of the Central American Isthmus. Its significance cannot be overstated. It's a vital artery for global trade, drastically reducing the distance and time it takes for ships to travel between the Atlantic and Pacific Oceans. Instead of circumnavigating the treacherous Cape Horn at the southernmost tip of South America, ships can simply cross this narrow land strip. Imagine a water elevator, if you will, that lifts these gigantic vessels over mountains and sets them down gently on the other side. That's the basic concept of the Panama Canal. Now that you appreciate the marvel of the Panama Canal, let's delve into the fascinating process of how a ship sails through it. Imagine a gigantic ship fully loaded, approaching the entrance of the Panama Canal from the Atlantic Ocean. The journey we're about to embark on is nothing short of a marvel of engineering. As the ship nears the canal, a seasoned pilot boards the vessel. This pilot, with years of experience and intimate knowledge of the canal's idiosyncrasies, will guide the ship through the intricate waterway. Before the ship even touches the canal, powerful tugboats spring into action. These tugboats, small but mighty, help navigate the massive ship towards the canal's entrance. It's a meticulously coordinated dance between the pilot, the tugboats, and the ship's crew. And then, there it is, the first set of locks. These locks serve a crucial role in the canal's operation. They're like water elevators, lifting and lowering ships to match the canal's varying water levels. With the ship securely inside the first lock, a magnificent process begins. Locked in place and ready to go, but how does a massive ship climb a mountain? Well, the answer lies in the ingenious engineering of the Panama Canal's lock system. Envision the locks as giant water elevators. They're designed to lift these colossal vessels over the continental divide and then gently lower them back down. The magic ingredient here is water, specifically water from Gatun Lake. Here's how it works. The ship sails into the first chamber of the lock system, and massive steel gates close behind it, effectively trapping the ship in a watery box. Now remember the water from Gatun Lake? It plays a crucial role at this stage. Water from the lake is channeled into the lock chamber, causing the water level to rise. No pumps are involved here, it's all down to gravity. As the water level rises, it lifts the ship upwards until it's at the same level as the next chamber or the lake itself. Once the water levels between the lock and the next stage match, the steel gates at the front open and the ship moves forward, essentially climbing the mountain one step at a time. But the journey doesn't end there. After passing through the lake, the ship approaches the descending locks. The process is essentially the same, but in reverse. Water is drained out of the lock chamber, and as the water level drops, the ship descends, once again trapped in its watery box, until it reaches the level of the next chamber, or the sea itself. So through a simple manipulation of water levels, a task that seems impossible, moving a massive ship over a mountain, becomes a reality. This feat is a testament to the marvel of engineering that is the lock system of the Panama Canal. Having successfully navigated through the lake, our ship now faces the final challenge, descending back to sea level. Descending might seem easier than climbing, but when you're a massive ship in a narrow canal, it's no less challenging. As our ship leaves the calm waters of Gatun Lake, it now faces the final set of locks. This is where we see the marvel of engineering at work in reverse. The ship, still guided by the tireless tugboats, approaches the Pedro Miguel locks. These locks serve as an elevator in reverse, dropping the ship down to the level of the Pacific Ocean. As the giant gates close behind the ship, the water starts to slowly drain out from the lock chamber. This is not done by powerful pumps or machinery, but by the simple yet effective principle of gravity. The water is let out through culverts embedded in the walls and the floor of the lock chamber, reducing the water level and causing the ship to descend. The process is repeated in the following lock chamber. The gates close, the water drains, and the ship descends further. This careful and precise process ensures the safety of the ship and the integrity of the Panama Canal. It's a ballet of steel and water, orchestrated by the lock operators and the ship's crew, all working together to navigate this man-made wonder. After the final descent, the ship finds itself at the level of the Pacific Ocean. The last set of gates swing open, and the ship, now on the other side of the continent, sails out into the wide expanse of the Pacific. The journey through the Panama Canal, one of the greatest shortcuts in the world, is complete. It's an awe-inspiring sight to think that this ship has journeyed from the Atlantic to the Pacific in just a few hours, traversing a distance that would have otherwise taken weeks. The Panama Canal, a testament to human ingenuity, makes this possible. And there you have it. A massive ship has just journeyed from the Atlantic to the Pacific, all thanks to the marvel of engineering that is the Panama Canal.